Hello, welcome to the series of AWS training sessions. I am Sridhar. So, in today's session, I'm going to discuss about the elastic load balancer and what an elastic load balancer is and how to create and configure the elastic load balancer on AWS console. So, elastic load balancer is used to distribute the traffic. So, in the current scenario, so I have the two web servers within a VPC. VPC is a private network. We're going to discuss about the VPC in our next sessions. But in our current VPC, like I have two web servers, web server 1 and web server 2. And both these web servers are configured to listen to my website. Let's say like my website is xyz.com. So xyz.com can be listened on web server 1 and web server 2. And on top of these web servers, I have an elastic load balancer. So what happens is like on the public internet, from the public internet on the browser, if someone wants to access the website, if you press xyz.com, the request will be directed onto the load balancer, and it is the responsibility of the elastic load balancer to distribute the traffic between the web servers. Like the traffic will be evenly distributed between web server 1 and web server 2. And if I have another web server, like to scale my website, like if I have another web server added to the elastic load balancer, web server 3, the traffic will continue to be redirected onto web server 1, 2 and 3. And coming to the benefits of elastic load balancer, as we discussed, elastic load balancer is used to distribute the traffic to the instances behind the load balancer, and we can have either one instance or more instances. If we have one instance, the traffic will always be redirected to one instance. But for high availability, we are going to have more than one instance. We can have like 2, 3, 4, 5 or 10 instances. And as part of high availability, the load balancer is going to check the health status of each and every instance. Load balancer is going to ping each and every instance and check if the system is responding properly or not. So health check is determined by the load balancer, and the load balancer is going to distribute the traffic only to the healthy instances. So load balancer is used to distribute the traffic, and it can be used for high availability and scalability. So currently, like in the example which we saw before, we have two instances behind the load balancer. But if we want to scale our application, we can add two more instances, and if we have four instances, the traffic will be distributed evenly to the four servers. So we'll look into the details on how to create the elastic load balancer on AWS console. So currently I have two Linux instances, Linux instance and Linux instance 2. So these are the two instances. So what I'm going to do is I'm going to configure the Tomcat application server in these two instances, and I'm going to configure the load balancer to redirect the traffic to one of these instances. So first thing is I need to configure the Tomcat application server. We can configure any application server and it's up to you. I'm going to configure the Tomcat application server on these instances and see how the traffic will be listened on to this one. So I already opened, instead of PuTTY, I'm using the third party remote MG tool, which is similar to the PuTTY. So now I'm going on to the Linux instance one, and here I'm logging as a super user, sudo su. So now I'm as a super user, so I can install the Tomcat application server now. Here yum install Tomcat 7. So you can learn about the Linux commands if you are not aware of, but I'm using the yum installer to install the Tomcat server, and I'm also going to install the sample application Tomcat 7 web apps. Yes, so I installed the Tomcat server and then web applications, that is sample application. And now next thing is I have to start the servers, Tomcat service Tomcat 7 start. So now in the Linux instance one, I installed the Tomcat 7 and I also installed the web application, the sample web application, and I started the server. So now the Linux instance 1 is up and ready, and I'm going to do the same thing on Linux instance 2. Sudo su to log in as a super user, yum install Tomcat 7 and yum install Tomcat 7 web apps. Okay, so now I have the Tomcat server configured in two instances. So now I'm going to browser and see if the Tomcat is responding on the web browser. Okay, now we configured the Tomcat application server in both these instances. Now I have two running instances and we configured the Tomcat application server in these two instances. So Tomcat listens on port 8080. So now first thing is we have to make sure that our security group. So this is the security group. We have it on the Linux instance 1 and 2, and we have to make sure that the security group is updated to listen to port 8080. So we need to open up the port. So what I'm going to do is I'm just going to right click and open a new window so that the security groups will be open in another window, and here I can look at the inbound ports and see. So currently we are only allowing port 22 and port 80, but as the Tomcat is going to listen on port 8080, we have to open that port. So I'm going to edit and I'm going to add another rule, custom TCP with port 8080 and everywhere and save. So now the security group is updated to allow port 8080, and we already have the Tomcat application server installed and configured. So now next thing is we'll look into to see if the instance is listening on port 8080 or not. So this is the public IP address, so I'm going to copy the public IP address of the instance 1. So I copied the public IP address, so I'm just going to see if it's listening on port 8080 and enter. So the first web application is listening on port 8080. So now our website is up and running, and let's look at the other website, second instance. So I'm going to the second Linux instance and getting the public IP address, and I'm going to make sure that the Tomcat is configured properly in this instance also. Colon 8080, enter. So here I am getting an error as your internet access is blocked. The reason might be because we might have not started the service. Yep, we can just start the service Tomcat 7 start. So now the service is up and running, and we'll go back to the browser and see. Just refresh. Okay, so now the two websites are up now. So this is the Linux instance 1 and this is Linux instance 2. So now what I want to do is I want to create an elastic load balancer, and the load balancer should direct the traffic onto one of the EC2 instances. So now if I go here on EC2 instances, here I can say the two instances are there now. So what I want to do is I want to configure the elastic load balancer. So whenever a request comes onto the elastic load balancer ELB, the ELB has to transfer the request onto one of these instances. So in order to configure the elastic load balancer, we can just go to the elastic load balancer here. Under load balancing, we have something called as a load balancer. And here I don't have any load balancers configured as of now, so I'm going to create a new load balancer to start configuring the load balancer. So I just click create load balancer, and here there are two types of load balancers. One is application load balancer and the other one is the classic load balancer. So classic load balancer was there since very long, and this application load balancer is been introduced recently, and the application load balancer operates at the application layer, and it allows us to define routing rules based on the content. So for now we are going to go with the classic load balancer. So click continue. So here I have to specify the load balancer name. I'm just going to specify like Tomcat App Server ELB, Elastic Load Balancer. And here we have to specify the ports. So load balancer port we have to configure here. So whenever we type the load balancer URL, so we need to specify on what port the load balancer is going to listen on to. So for Apache, for Tomcat, it's listening on 8080, and we can configure the load balancer to listen on port 80, which is the default HTTP port. And I want to make it listen on port 80 instead of 8080. So in that case, I'm just leaving it as 80. And coming to instance protocol is HTTP and instance port. Instance port in the sense the instance is currently listening on 8080. So this port we have to specify here as 8080. So now we are configuring the elastic load balancer, and the name of the elastic load balancer is this one, and it's within the default VPC, and the load balancer is going to listen on port 80, but the traffic will be redirected to the instance on port 8080. Load balancer will receive the traffic on 80, but it's going to redirect the traffic onto the instance on 8080. And next thing is assign security groups. And here, instead of creating a new security group, I'm going to assign the existing security group, which is the launch wizard one, which is being used onto the instances. And here we know that in the security group we already opened port 80 and 8080. Both the ports are open, so this should be good. Here it's just giving us a warning because we did not install or configure the SSL or HTTPS. That's fine, we'll just go further and configure the health check. So now we have to configure the health check of the instances. So currently the instances are listening on the root on port 8080. So if we have like /index.html or index.aspx, that part we have to configure here, but currently the Apache Tomcat server is listening on the root on port 8080. So the load balancer is continuously going to ping to this instance port on port 8080 on the root to see if it is healthy or not. So if we are using IaaS or JBoss or other application servers, we have to give the ping port to the one which is listening on that web server, because now we are configuring the Tomcat. The Tomcat is listening on port 8080. I'm just specifying the ping port as 8080, and ping path I'm just specifying as the root, because we don't have any other specific files to be given here. And there is one more section called as advanced details. So under advanced details we have to specify the response timeout. So continuously the elastic load balancer is going to ping to the instances, and here we have to specify the timeout. So if it is 5 seconds, the load balancer has to get the response within 5 seconds. If the load balancer is not going to get the response within 5 seconds, the instance will be treated as unhealthy. And interval. So how often the load balancer has to ping to the EC2 instance? So if we give 30 seconds, the load balancer will continuously try to ping to the EC2 instance for every 30 seconds. But for our testing, I'm just going to specify the timeout as 2 seconds, because we don't have anything other than the sample application. It should get the response within a second, so I'm just giving it as 2 seconds. And instead of waiting for the interval of 30, I'm just going to make it like 5 seconds. And here we have to specify unhealthy threshold. So if we give the unhealthy threshold as 2, so what happens is the continuously elastic load balancer is going to ping to the EC2 instance. If it is not going to get the response within 2 seconds, if the instance is down or if the instance is not responding for some reason, and if the server is not responding for 2 consecutive times, the instance will be marked as unhealthy. And if we specify 5, it will wait for 5 times to ping to the server and see if it is responding. And if it don't respond for 5 times, then the instance will be marked as unhealthy. And for our testing, I'm just specifying as 2. and healthy threshold I'm going to specify as 5. And next is add EC2 instances. So now we configure the health check, and next thing is we have to specify what EC2 instances will be behind this elastic load balancer. So for that I'm just going to the next step, add EC2 instances. Now we have two EC2 instances, and the two EC2 instances must be under this load balancer. So I'm going to add two EC2 instances here. So currently the running instances will be shown here. Now we only have two, and I want these two to be part of my load balancer. And add tags. Name Tomcat ELB. And review and create. So we can just verify our configuration again, the load balancer name, and the load balancer is going to listen on port 80, and the request will be forwarded on to the EC2 instances on HTTP on port 8080, and health check is on HTTP. The ping will be done on HTTP on port 8080, and the timeout is 2 seconds. The interval is going to be 5 seconds. For every 5 seconds the load balancer is going to ping to the servers to see if the servers are healthy or not, and unhealthy and healthy thresholds are 2 and 5. And I'm just going to create the load balancer. So now the elastic load balancer will be created. So now I'm going to go to the elastic load balancer here. See, now here we see an elastic load balancer which has been created by us. So if we go to the details under the description, so for each elastic load balancer we are going to have a DNS name, and this DNS name should be used to access the load balancer on HTTP port 80. And we did not discuss about the availability zones. We are going to discuss about this, but this load balancer is an internet facing, and we have two instances, and out of two instances 0 instances are healthy because we just created, and it's going to take some time to get the instances up and running. So if you go to the instances, we can see the instances which are under the load balancer. So now currently these two instances are under this load balancer, and these two instances status is shown as out of service because it is still initializing. Instance registration is still in progress. So it will take a couple of minutes to get this into in service. So I'm going to pause the video for a minute and get back. Okay, so now the two instances are showing as in service. So no errors. And if we go to health check, this is the health check information which we already gave at the time of creating the load balancer. Okay, now to see if the load balancer is responding properly or not, I'm just going to access this on the browser. So I'm just copying this, and on the new tab I'm just going to paste this. So now the load balancer is going to listen on port 80. So because 80 is the default HTTP port, we don't have to specify the port number here. So now we are getting the response. So what happens is whenever the request comes onto the elastic load balancer, this is the ELB. So whenever the request comes onto the elastic load balancers, the request will be redirected to one of these instances. So now the elastic load balancer is listening, and the traffic will be redirected to one of these EC2 instances. So now I'm going to the AWS console, and here we have one more tab called as monitoring. So all the log information will be captured in one of the service called as a CloudWatch, which we'll be discussing later. But here this information will be retrieved from the CloudWatch. So here if we go to the monitoring, under monitoring we can see like how many unhealthy hosts are there. So now unhealthy host is 0 and healthy host count is 2. And this looks like a graph after some time because we just created the elastic load balancer. It's just showing as a dot because the metrics will be collected for every 5 minutes. It's going to take some time to show it as a graph. And here it also shows about like average latency to see like how much time it's going to take for elastic load balancer to respond back. And these are some of the metrics available under the monitoring. So this will be helpful to debug if there is any issues. So now under this load balancer we have two instances, and the two instances are up and running. So let's say, like, what happens if one of the instance goes down. So I have two instances, and I'm going to the EC2 dashboard or EC2 instances. So there are two instances healthy, so I'm going to stop one of the instance. I'm going to instance state. To stop the instance, I'm selecting the instance, going to the actions, instance state, and stop. So what happens is one of the instance is going to be stopped now. So now only one instance should be up and running. The other instance is stopped. So we'll go back to the elastic load balancer and see the instance health check. So going to the ELB load balancers under load balancing. So here we'll go to the instances. See here, this instance is marked as out of service because the instance is now shut down, stopped, and it's not going to receive the traffic. See, if I go here, I think this is the instance one. See, this is not responding, and this one is responding. See, the instance one is down, so it's not responding. But what happens to the elastic load balancer? So the load balancer will be still up because the traffic will be redirected to the instance which is up and running. So this is the instance which is not up, and this is the EC2 instance, the second EC2 instance which is up and running. So because the elastic load balancer marked one of the instances as unhealthy, all the traffic will be redirected to the healthy instance. So this also can be used to configure the high availability. So even though one of the instance is down, our application is not going to fail because the traffic will be sent on to the other instance. And if we go to the monitoring, we must be able to see the unhealthy, and see, this one has become unhealthy. So healthy count has come down to 1, and average latency will be increased because it's going to be only one instance. So this is about the elastic load balancer, and that's it for now, and we'll see in the next session. Thank you.